This presentation is about Android anti-patterns. So it's a retrospective from a couple of our sprints. And we'll go through them one by one. So an anti-pattern is a common response to a recurring problem that is usually ineffective and usually counterproductive. And we have Bush here and a soldier. Does anyone know what it is?
Leadership or what?
What?
I assume it's a leader that the other people.
Yeah, there's a leader, and they are all running, but it's actually premature optimization.
Okay.
So, so that's a term that Donald Knuth introduced on Case Institute of Technology, and he says, or actually he thinks, that premature optimization is the root of all evil. He actually wrote a book and an article about anti-patterns, and you can look it all up in the links from the presentation. And there is also another guy, Tony Hoare, who, well, there is some discussion who actually said that premature optimization is the root of all evil, but yeah, these guys think so. And also, Knuth said that we should forget about small efficiencies, say about 90%, 97% of the time. Especially if you do not work in strict memory or CPU cycle limits. And coming from our project, this is when somebody said that we should, or actually all of you said that we should remove all enums from the project. And that's a common thing to say, well, let's do it. But actually, why? Why should we remove all enums? Enums have obvious benefits. They make the code more self-documenting. The compiler can tell you stuff. It's actually like a class, so there is type checking, correctness. And it prevents you from writing illogical code. Like if you represent enums by ints, you cannot, for example, I don't know, add enums. Well, you can, but immediately you see that it's wrong. And what do you mean by changing it to integers? It's like this, or maybe it's not a good idea. Maybe we should do it like they do in the SDK, with the int_def annotation. With the link here, if somebody wants to use it. But if you did it like the Android guys do it, it would leave you with this. So you have ints, which represent enum states or enum values, and you have an interface visibility with all the states put into int definition. But ProGuard does it for us, so why should we do it by hand if ProGuard already does it? So if you use ProGuard, let's forget about enums, or like they are already changed to ints in the compilation process, so why should we do it? If you want to keep some enums because they are shortened to A, B, and C names, if you use like a name of the enum somewhere in the code, you can actually prevent ProGuard from shortening it and changing it to integer values by this. And we actually use it in our project for a couple of enums. And there is also some Stack Overflow links to, well, when the guys talk about it. So summarizing, well, no, premature optimization is not a good thing. And you should always think if it's reasonable to introduce something. What about this? What anti-pattern is this?
Silver bullet.
Yeah! So it's silver bullet, exactly. And our silver bullet is, of course, RxJava. So we should all do everything in RxJava. Which is like a cool library. And Reactive is it's a cool pattern, of course. But it's heavy, especially on Android. It's heavier than Kotlin, like a separate language is smaller than RxJava, with only RxJava and with are all libraries.
You forget Eric's Android.
Oh, sorry. Okay, so it's even actually, if we would keep on adding libraries, we would hit the limit. But fortunately, we didn't. Comparing to all the Android classes, which are 9,000 methods, our RX Java 5,000 seems like a lot. But it's only before programming, so maybe but still, it would be nice to debug the application without multi-text. So when should we use reactive patterns? Maybe sometimes it's enough to use Android bindings, for example, for clicks. Well, I would use reactive when there is constant flow of data. When there are some patterns where you can use debounce or throttle first, for example, instant search window, or like we did with GPS coordinates. These are the places where we should use reactive patterns. But maybe like reflecting settings in the UI, should we use reactive there to reflect the changes? Maybe yes, maybe not. Maybe bindings are enough. If that's the only place where you would use reactive, maybe it's not reasonable to put it there in the first place. So yeah, like I said, I wouldn't use reactive for button clicks, simple lookups from database, where you just find only one object from the you're looking for one object from the database, and you actually don't need to observe it. And I wouldn't use reactive for large, expensive cached objects where you need a lot of computing power to look for the changes constantly, for example, every second, and see if there was a change and then emit an observable. So yeah, so it depends on the implementation. Like in Android shared preferences, you have that listener, so it's not cost expensive. But if you don't have the listener, then you would need to constantly search through the list if it was changed. What about this? Duplication. Yeah, duplication. So that was part of the thing that I showed earlier. And yeah, I wouldn't want to duplicate reactive approaches. Taking into account RX Java and event bus, they are both in a way reactive because they react to change. You in an event bus, you subscribe to events published by the publisher, so you can easily implement it with RX Java. Yeah, I wouldn't use a separate library for that. And that's actually a couple of lines of code we used to implement our RX event bus or RX event quick. What about this? Null pointers or null pointer hell. Yeah, so we had that approach with non-null, and Java is unfortunately not null safe, and it will probably, well, maybe not ever be, but not in the short run. How can we overcome this? We could use a higher order language like Kotlin, Scala, or Dart, or use the optional type, but you can also use annotations. And we ended up doing non-null annotations for every possible parameter in a function, and that was tedious, obviously. So we did that approach assuming that parameters and return values are non-null by default. And we did that by generating package info files for every single package in our application. And to ease up the process and exclude it from Git, we actually wrote some Gradle tasks that automated for us. Summarizing AntiPatterns, we wouldn't want premature optimization in our project, silver bullets, duplication, and null pointer hell. And some couple of other AntiPatterns are, for example, superstitious coding, where you code in every possible error until they are almost impossible, but they are there and they take up space. Reinventing the square wheel. I hit that problem like a couple of companies before this one, where they actually wrote big systems for themselves, and sometimes then they ended up with the technology being obsolete, and that's a huge problem. Um, so if there are open source libraries that work, maybe it's good to use them. Um, Tester-driven development is when actually you don't have time to invent your own features and think about how the program should work. It's only the QA team that constantly uh, files you bugs and tells you like they tell you how the program should work, and maybe it's reasonable to sit down and think how it actually should work, not put everything on the QA team. And lava flow is where you have, like Camille said, when we have portions of the code that are hard to refactor, and they are there, and it's not reasonable to ever remove them, but we should. So, because otherwise we would have lava flow all around the project. These are the links. For premature optimization from Knuth and other anti-patterns, when to use reactive and where not. These are our Gradle generators, Gradle tasks. Yeah, and a couple of articles about enums on Android, and that would be all. Any questions? Like, if you don't agree.
I don't agree with what I mean. Enums.
With enums.
Yeah, I used enums before in our project. I just forgot about using them in some cases. You know, it's like a bad habit I have. So I don't think the enums are evil, and I think we should use it when it's okay to use it. Like in when it's
Yeah, because the problem is that
benefits.
they take up memory. Yeah, every time you run the app, and the more you have them,
Okay.
like the more you have of enums, the more memory you take. But maybe we don't. Well, how many enums do we have actually?
We have one or two right now, so we don't have the problem. And
Yeah,
let's use even more.
probably.
Yeah.
I was thinking about the cost of refactoring
Okay.
and like and all the benefits of having enums in the code. So they are in a way self-documenting, and you have the possibility to translate them, for example, if you want. And well, these aren't actually classes, but well, kind of classes. So enums are much more powerful than integers.
Okay, so I agree with that. This is an obvious anti-pattern, but I don't think we choose to not use enums because they are evil or heavy. Personally, I didn't choose to use integers over enums. This is just my mistake, you know.
Oh yeah, okay. So yeah, because it was yeah, the anti-pattern was actually premature optimization. So we had a discussion about removing enums, and I thought, well, maybe we should investigate on that and see how much performance are we actually getting, especially with ProGuard, and about the cost that we would have to deal with removing them. So it's not actually about enums being evil or good, because like these benefits are obvious in a way, but it's about thinking, is that the right moment to remove them? Or like maybe we should if we had serious problems with performance, maybe we should remove them.
I don't think so,
but
because we have only two enums. If we will have, I don't know, 10, 15 enums, yeah, I will have to thinking about to change it on.
Yeah, so it's like
in constants with annotation supports, yeah. And it's one issue because if you want to add enum, yeah, if you use ProGuard, you can't forget about adding it to ProGuard because in release mode application will crash.
Yeah, and especially that in a default way it will be ProGuarded, so well you have to especially exclude it. But it was more about thinking whether it's the time to optimize it. Well, whether it's a good time for the project to optimize things, especially in such a small way. Well, it's optimization is always a matter of cost, so it costs you something to optimize it, and in that pattern, Knuf says that maybe it's, well, you need to think if it's reasonable to optimize something, because some things are easy to optimize and others aren't. So yeah, so it was only about actually thinking about it, well, whether we should do it or not. And not jump into conclusions like this guy on the right. So yeah, Any other questions?
Okay, so I will read when to use or when to not use Rich Java.
The link.
And I think then we'll talk about it on Monday. Yeah. So.
But it's actually we actually use it wrongly only with the clicks, so it's not that bad.
I agree. The Eric's binding library was a mistake.
So it was substitute for,
because it's actually for GPS. It's useful for database more or less. Maybe it's heavy, but well, it's useful for us. Where else? Location causes problems, but it's useful. Especially that it's a constant flow of data.
Database.
It's useful, but it's heavy. It should be optimized. But if we want it,
but Realm has RX extension inside.
Yeah, I know.
Which causes many problems.
Yeah.
Maybe it's not mature enough.
Because it's not a perfect solution.
Yeah, so we will definitely need to have a discussion on that, but we are quite close to being in a good shape. So,
okay.
Any other questions? Thanks.